Okay, so we'll see now how to implement loops and arrays in SAS environment. Loops and arrays are widely implemented in business scenarios or cases where you have a business logic that you want to repeat a number of times. So in case if you want to process certain business logic some specified number of times, instead of repeating those statements again and again in your SAS program, you can have that statement recorded or embedded within a loop, and you can instruct loop to execute that particular statement specified number of times. So we have two types of loops in SAS environment. We have something called as iterative looping, and we have something called as conditional looping. So we have two major types of loops, iterative loops and conditional loops. Iterative loops are the ones where you know precisely how many times loop is going to execute. Conditional loops are the ones which will execute as long as your criteria is true or condition is true. We are going to demonstrate both these types of loops in our today's discussion. So let's start with this iterative loop. So in a given business scenario, if you know that you want to repeat certain business logic 5 times or 10 times or 20 times or 100 times or 1000 times, you can make use of this iterative looping. Wherever you do not know how many times the loop will iterate, rather you know when to stop the loop, you can go for conditional looping. So let's try to understand these two concepts on loops with the help of certain examples and demonstrations. So let's say there's a person who is investing say 5,000 rupees in a bank, and he wants to know what is the earning at the end of the year when he selects the interest mode as yearly and quarterly. Let's say the interest rate for this is 4.5%. So he wants to compare the interest that he earned in when he selects or when he goes for yearly mode or when he goes for the quarterly mode. So we'll first write a code where we'll try to calculate the interest in yearly and quarterly mode without using loop, and then we'll introduce loops and we'll see how to implement the same using iterative looping. So let me write a data step where I'm going to demonstrate a loop. So I say data compound, let's say this is the name of my output data set. I'm not reading any input data set in this case, everything is hard coded. So I just say amount is equal to say 5,000 or 50,000 say. So amount is equal to 50,000. Then I say rate is equal to, say rate is 4.5%. So let me write it as 0.045. And now let me calculate the interest when the person goes for yearly mode of interest and when the person goes for quarterly mode of interest. So I say let me calculate the interest and store it in a variable, say yearly. So I say yearly is equal to amount into rate, and then I say quarterly. Let's say this is my second variable where I want to store the quarterly interest. So I say quarterly is equal to, or I say quarterly plus quarterly plus amount into rate divide by 4. Let me copy this statement and let me calculate this for 4 quarters. So this is for first quarter, this is for second quarter, this is for third quarter, and this is for fourth quarter. If you see in this particular demonstration, to calculate the yearly interest, I have used assignment statement because this is one time calculation. But that's not the case with quarterly. When the person goes for quarterly mode of interest, whatever interest he earns at the end of quarter 1, that is reinvested in quarter 2, and then the quarter 2 interest is calculated on that principal amount and the interest earned in quarter 1. Whatever interest he earns in quarter 2, that is again reinvested in quarter 3. Quarter 3 interest is reinvested in quarter 4. That's the reason why you need to write a sum statement here, so that you retain the previously calculated interest and use it for the next quarter. That is not required for this yearly interest because this is one time calculation, but this you are calculating for 4 quarters, and in every next quarter you have to reinvest the interest earned in the first quarter. So I say run, and let me execute this data step. So data step has executed and it has created my data set. I say proc print data is equal to compound and run. So if you see here, these are the values which has been written to my output data set. So my output data set has one observation where you see this amount value appearing as 50,000. This was my capital amount. Then this was the rate. This is the interest calculated in yearly mode, and this is the interest calculated in quarterly mode. So now you can compare and see where the earning is more, and you can go for that particular mode of interest. Now in this particular scenario, we calculated the yearly interest and quarterly interest for 1 year. What if someone asks, excuse me, what if someone asks to calculate this for 20 years? In that particular case, you'll have 20 statements to calculate this yearly interest, and you'll have 20 into 4, that is 80 statements to calculate the interest for 80 quarters. So you'll have 20 statements for year and 80 statements for quarter. 100 statements would be added in your program just like that. So a program which has so many statements will take more processing time, and it's not good from resource utilization point of view. That will need more RAM, that will need more hard disk, that will need more IO, CPU utilization. So from optimization and efficiency point of view, that's not a good approach. So a good program is the one where you have achieved the task in minimum number of lines. So just because someone wants me to calculate this for 20 years, I have added 20 lines for yearly interest and 80 lines for quarterly is not a good idea. So in this particular case, we'll have to introduce loops where I can also reduce the number of lines that you see in my current code. So in my current code, I have some 5 lines, 1 to calculate my yearly interest and 4 to calculate my quarterly interest. This 4 quarterly interest lines, I can convert it to 1 and calculate it not for just 1 year or 20 years, I can calculate this for n number of years. So let's see the modified code. So let me rather write a new code where I'm going to implement the same task but using loops. So you can avoid loops in case if you have only few number of iterations to perform. But in case if you have large number of iterations or large number of statements which is implemented towards a business logic to perform, in that case writing those code statements is not a feasible programming, rather you should go for implementing loops. So let's see how to convert the same task using a loop. So I'll write another data step. So I say data compound I say amount is equal to 50,000, rate is equal to 0.045. Then I say, okay, let me specify the loop. So to calculate this interest for 20 years, I say do I is equal to 1 to 20. And then I write my statement to calculate the yearly interest. So I say yearly plus amount, yearly plus amount into rate. Then I say end. So you start the loop by writing this keyword do, followed by an index variable which is going to count the number of iterations of your loop or keep track of the number of iterations. This is the start value and this is the stop value of the loop. So this do, to, end are the keywords that I have used in the loop. So you need to say do, some index variable, ensure that you have selected a valid variable name. So you can select any name, I, J, K, L, M, N or X, Y, Z, any name, valid name can be selected here. And then you need to specify a numeric value which represents the start value of the loop, and then you need to say 2, and then after that you need to specify the stop value for the loop. So I'm saying do I is equal to 1 to 20, yearly plus amount into rate. Now if you see, unlike my previous scenario where I created this variable yearly with the help of assignment operator, here I'm using some statement that is something similar to this quarterly interest calculation, because this time it is for 20 years and whatever interest you earn at the end of year 1 is reinvested for year 2. Year 2 interest is reinvested for year 3, year 3 interest is reinvested for year 4 and so on. So this has to be assigned, or this has to be calculated using some statement where you are able to retain your previously calculated interest and add it to the amount and calculate the interest for the second year and so on. Now let me specify a similar statement to calculate the interest in quarterly mode. So I say do I is equal to 1 to 80. So this is for 20 years, that is 20 into 4, 80 quarters. And then I say quarterly plus amount into rate divide by 4. You'll have to say rate divide by 4 because these rates are for the entire year and this is something that you are calculating for one quarter. So you need to say rate divide by 4 to indicate that this is some amount calculated for only first quarter. Then you have to say end to end your loop. So I have specified similar statements in my, or similar business logic in my first loop and the second loop. First loop where I am calculating this interest for 20 years and second loop where I am calculating this interest for 80 quarters. I say run. Okay, so after ending my loop I say run and let me execute this code once again. So we missed semicolon somewhere in our program here. That's the reason why we got this error. So I put a semicolon here and execute my program once again. So it has created my data set. I just say proc print data is equal to compound. So as you see, in my yearly mode, I earned an interest of 70,585.70, whereas in quarterly mode, I earn an interest of 72,363.75. So again, you can compare and see where the earning is more. Again, if you observe one thing, this index variable value is printed as 81. This was the iteration where my last calculation stopped. So the moment the value of I became 81, after calculating the interest for 80 quarters, the loop stopped. So this index variable value which is printed here is one more than the loop where this amount was calculated. So this 72,363.75 was calculated in 80th quarter, but the index variable value which is printed here is 81. Please remember, when you output only the lastly calculated result, then the index variable value which is printed is one more than the stop value of the loop. So this is creating a little confusion. So it's better that you drop this variable and do not write it to your output data set. So just say drop is equal to I, so that it is not written to my output data set and there is no such confusion. So execute this once more. So if you see, I'm getting only amount now, rate, the yearly interest and the quarterly interest. So this was the interest that I earned at the end of 20th year, and this was the interest that I earned at the end of 80th quarter. This is printing only the last quarter's calculated amount or the last year's calculated amount. In case if you are interested printing everything, all the yearly interest, meaning what was the interest calculated at the end of year 1 and then year 2 and then year 3 and so on. Similarly, I want to calculate all the interest earned at the end of every quarter. So let me add this keyword output so that it writes every calculated result to your output data set. So let me write an output here for yearly interest and let me write an output here for quarterly interest. So I just say here output. So now if you see, it is writing 100 observations and 4 variables. So if you see this, first 20 observations in this output represent your interest earned at the end of every year. So this was the interest earned at the end of year 1. This was the interest when this year 1 calculation was going on. That time the quarterly calculation was not started. That's the reason why everywhere it is showing a value 0. So this was the interest earned at the end of year 1. This was at the end of year 2, year 3, year 4. If you just scroll this down and see the 20th observation value, if you remember, when I was outputting only the last observation, this was the amount that I was seeing in my output data set. Now 21st observation is the observation from which your quarterly interest calculation began. So if you see, this was the interest earned at the end of first quarter, first year, first quarter, first year, second quarter, first year, third quarter, fourth quarter, and so on. Like this, if you see, the last observation is 80th observation, where you calculated an amount which was 72,363.75. Now again, if you remember, this was the amount which was getting printed earlier when I was writing only one observation. So I hope this is clear to you how to use an iterative loop. We'll see some more examples to have more confidence on this topic. Before I switch to the next demonstration, one more thing, please remember, this is the syntax of iterative do loop in SAS environment, where you say do I is equal to 1, 2. You specify your start value and then say 2 and then the stop value. By default, the loop increments by 1. In case if you want to increment it by 2, then there is a keyword called as by 2, or you can say by 3. So by whichever number or amount you want to increment your loop, just write by keyword and followed by that number. So if you say do I is equal to 1 to 20 by 2, then the loop calculates this yearly interest for the values of I is equal to 1 and then 3 and then 5, 7, 9, 11 and so on. So every time the loop increments by 2, and you will end up calculating only 10 years, because it is going to calculate this only for the odd years, and it is going to skip the even years because you are incrementing the loop by 2. So it will be calculating it for I is equal to 1 and 3 and 5, 7, 9, 11, 13 and so on. So please remember, by default the loop increments by 1 if you do not specify anything. So this was a quick introduction of iterative do looping. Now let's see the next scenario. Now in our next business scenario, let's consider that there is a person who is investing, say, rupees 5,000 for 3 years in a bank, and we need to calculate. So for a given interest rate, we need to calculate what is the amount that he is going to accrue or that he is going to get at the end of third year. So unlike our previous scenario, this time the person is investing this rupees 5,000 for 3 years. In earlier case, it was one time investment and then we calculated the interest for 20 years and 80 quarters. But this time the person is investing this 5,000 rupees every year. So he is getting some interest on his initial investment. At the same time, in subsequent years, he is investing some more capital to this, and we need to calculate how much money he is going to get at the end of the third year. So that's our business scenario. Let's say the person started investing in a specific year. So let's say the person started investing in, say, 2014. So he invested 5,000 in 2014 and then 15 and 16. We need to calculate how much money he is going to get in 2016. So we'll implement this with the help of a loop. We say data, let's say calc interest. You can name this data set anything that you want. I say do I is equal to 1 to 3, because this is 3-year investment. Then I say capital or amount, whatever variable you want. I say capital plus 5,000, and then I calculate a interest on this. I say capital plus capital into 0.045. In earlier business scenario, I stored this rate value in a variable and used it in my expression, but now I'm directly using it. Suppose this is the interest rate and this is the investment which the person is doing every year. Okay, so we have specified a sum statement to consider every year's investment. So as you know, this is a sum statement, and recall the features of sum statement. What we discussed in our earlier session, that if you create a variable using sum statement, that variable is created in memory, it is assigned an initial value 0, and then whatever appears on right hand side gets added to that variable. So it is like 0 plus 5,000, that's the first year's investment. And then you are calculating some interest in first year by saying capital into 0.045, and that interest is added to this capital amount. So it is like 5,000 plus some interest calculated on 5,000. We'll say end and run. So this is like in first iteration, this is like 5,000 plus 5,000 into 0.045. So say this amount is say some 225. So this 225 is added to 5,000. So at the end of first loop, this capital becomes 5225. Now again, when the control goes back to this loop, when the loop increments to 2 and condition is true, it enters the loop, and again this 5,000 is added to the previous capital and interest, which was 5225. So now it is 10,225. So this is like 10,225 plus interest calculated on 10,225. This interest is added to this capital, and again when this control goes back to this loop for the third time, again 5,000 is invested or added to that existing capital and interest calculated for the third year. When this loop value becomes 4, the stop value becomes 4, the loop terminates, because in that case this goes beyond your stop value, and the loop will terminate, and whatever you have at that point of time is written to your output data set. So let's proc print this output data set and see what observation is created and written to the output data set. So I say proc print data is equal to calc interest and run. बंद कर देना था. So if you see, this is the observation written to the output data set, where the capital value is written as 16,390.96. If you see the I value, as we discussed earlier, when you output only the last value calculated by your loop, the index variable value which is written to the log is one more than the stop value. So the loop actually stopped at the end of third iteration, but it has incremented the index to 4, and then it checked the criteria and that was found to be false and loop stopped. So it printed the value 4. Now instead of using this this index variable I or a variable name as I, we can give it some meaningful name, and we can write this in our output data set and make our results or output more interpretable or meaningful. So we can say, instead of saying do I is equal to 1, 2, 3, we can say do year is equal to, and we can write here 2014 to 2016. Even in this case, the loop executes only 3 times for the value of year is equal to 2014, 15 and 16. So instead of saying do I is equal to 1, 2, 3, if you write year is equal to 2014 to 2016, and if this year values are written to the output data set, that makes your output more meaningful. So let's execute this and see how the output is written to the output data set. When I proc print the observations written to the output data set, this is what I'm getting. So as you see, in this case also, the year is printed as 2017. So we discussed the solution for this. When you are writing only the last calculated result, the index variable value will be one more than the stop value. But if you print every calculated result, then it shows the index variable value correctly. So just before this end, if I write output and print the interest calculated at the end of every year, that is at the end of year 2014 and then 15 and 16, then that 17 will never appear in your output. So when I output every prepared observation, rather than writing only the lastly prepared observation, execute this data step, and now write this proc print. So if you see, this is what I'm getting. This was my amount capital at the end of year 1. This was my capital at the end of year 2. So some interest was calculated in year 1 which was added to capital. So 5,000 was the investment and 225 was the interest calculated. So that's how it was 5225. Now in that 5225, 5,000 was added in next year and then interest was calculated. So it is 10,225 and then the interest calculated which was around 450. And then 10,685 plus 5,000, that is 15,685, and then interest calculated in third year, which made this amount as 16,390.96. If you remember, this amount was written for year 2017 when I was writing only the last observation, but this was actually the amount calculated in third year, that is 2016. That's the reason why most of the time when people write only the last observation, they prefer dropping the index variable because that creates confusion. So index variable value will be shown one more than the stop value doesn't mean SAS has calculated the amount in that particular year. Okay, so this was the second example on loops. We'll see more examples on this to create a good understanding on this topic. This is one of the most frequently used topic in SAS environment. So let me implement the next example. If you remember, in one of our previous sessions, we created a forecasting application for a data set called as growth. So if I proc print the data set growth and show you the kind of data that we had in the data set, I say proc print data is equal to, let me create a library reference. So I say lib name Orion, that is some library reference name, and then I say C drive SAS Foundation PRG 2. So I created a library reference, and now let me show you the kind of data that we had in that growth data set. So I say proc print data is equal to Orion dot growth, and I say run. So if you remember, this was the data set where we were given some number of employees, total employees in different departments, and then we were given this rate of increase by which employees are getting added in each of these departments. And then we were asked to calculate the number of employees at the end of year 1 and year 2. So if you remember, in this topic only we learned the concept of explicit output. So let me rewrite that code once again, and we'll convert that code into a loop demo. So at that point of time, we were asked to calculate the number of employees with this rate of increase at the end of year 1 and year 2. That was only for 2 years. What if someone asks me that you calculate this number of employees for 10 years? So tell me, at the end of 10th year, or for 10 years, at the end of every year, you calculate how many more people will be added to each of this department. Now implementing this without loop would be a code which will have n number of lines. But if you implement this business logic using loops, just by specifying one line of business logic, you will be able to calculate this not just for 10 years but even for 50 years or 100 years. So let me rewrite that code and then we'll convert it to a loop example. So this was the demo that we discussed in our one of the previous sessions. So I say data forecast, Then I say set Orion.growth, and then we say year is equal to 1, and then total underscore employees is equal to total underscore employees into 1 plus increase. And then we said output, because when I calculate this for second year, my second year values will override the first year values. So in case if you want to print for both the years, year 1 and 2 both, in that case you need to ensure that you write output before you start calculation for the second year. So now I say, now it's okay if year is equal to 2 overrides my previous statement where I said year is equal to 1. Now I'm okay if this total underscore employees calculation overrides my previous total underscore employees calculation, because I have already written it to my output data set. So I say total underscore employees is equal to total underscore employees into 1 plus increase. And then I say output and run. I execute this. So it is reading 6 observations from my input data set and writing 12 observations to my output data set. I say proc print data is equal to forecast and run. So if you see, these are the number of employees written at the end of year 1 and year 2 for each of the departments. So in administration at the end of year 1 you'll have 42.5 employees. At the end of year 2 you'll have 53.125 employees. If you want, you can round off these total employees values, but this would be the number of employees at the end of each year for this given rate of increase. Now if the same code I convert for 10 years, meaning now people have asked me to create this output data set which should have the number of employees for 10 years for every department. So I want to calculate the number of employees in administration at the end of year 1, year 2, year 3, year 4, year 5, year 6 till year 10. So I have total 6 departments, and for one department, if I am writing 10 into 3, 30 lines. So if you see, this 3 lines are calculating it for 1 year. These 3 lines are calculating it for 1 year. Same I'll specify for second year. So 3 lines for 1 year, meaning for 10 years I'm going to specify this. This has 30 lines. So 30 lines for year 1 and then 30 lines for year 2. So total 60 lines I need to specify to compute number of employees in every department for 10 years. Just imagine a program where you have 60 lines only to calculate some value is not a feasible code or good programming. Rather, in this particular case, if you make use of loops, you can reduce the number of lines. Even in this current format, you can eliminate some number of lines and reduce the size of this particular code. And if you have less number of lines in your code, that needs less resources to compile and execute. So a program which is written in minimum number of lines is resource friendly. So that's going to save your CPU utilization, your RAM, your IO, your disk space, and various other resources. So let me write a code where I'm going to calculate number of employees in every department for 10 years without adding extra lines in my code. In fact, I'm going to remove 3 lines from my existing code also. I'm going to calculate this for 10 years. Let's see how to do that. So I say data, forecast, then I say set or and.growth, and then I say do, year is equal to 1 to 10, and then I say, let me specify the expression to calculate total number of employees. So I say total underscore employees is equal to total underscore employees into 1 plus increase. And then I say output and run. That's all. So if you see in my this code where loop is not implemented and where I calculated it only for 2 years, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. Whereas in this code, which is calculating number of employees for 10 years for all the 6 departments, I have number of lines as only 6. So I have eliminated 3 lines from my previous code also, but this code will calculate the number of employees for 10 years.